Hi guys, welcome everybody. Continue with the method of the rings about the solid revolution. We're going to work with the next example. Here we have two functions. The first one is f for x equal to x squared plus 2. It's a parabola, and the other one is g of x equal to 1. In that case, it's not a parabola. We're talking about that constant. Okay, so here we are going to continue with the axis of x has the axis of revolution, and as you can see, if we made here the representative differential rectangle, and if I make the revolution of that rectangle, I'm just gonna have this part. Okay, in that case is going to be the correspondent ring. Okay, and the figure that we're going to have is going to be something like that, more or less something like that. Well, it's going to be something like that. Okay, sometimes it's kind of difficult to draw it, but whatever. Here we can see that here we're going to have a hole. Okay, we're going to have a hole, so that's why we are going to work with the method of the rings. Okay, well, here the method of the rings, remember that you want to calculate the volume. It's going to be equal to pi of the integral from a to b of some function that is going to be f for x squared minus g of x squared dx. Remember that the first one should be the external radius, and this one should be the internal radius. Okay, so according with my problem, I'm going to write over here pi from, in that case, we start in 0 and we're going to finish in 2. From 0 to 2 of the first function is going to be x squared plus 2 squared minus 1 squared, that is the second function. First of all, we need to develop this binomial. Then we have a square binomial, and if I develop, it's going to be the square of the first one. It is x to 4 plus 2 times the first and the second is going to be plus 4 x squared plus the square of the second, that is going to be 4, minus 1 squared, that is going to be just 1 dx. Okay, at the end we're going to have 1, 2 and 3 different integrals. The first one is going to be pi from 0 to 2 of the x to 4 dx plus 4 times the integral from 0 to 2 of the x squared dx. And then here is going to be, we forgot here the number, the pi, and 4 minus 1 is 3. It's going to be plus 3 pi of the integral from 0 to 2 of dx. Okay, this is the correspondent three integrals. Here we're going to have the result. The first one is going to be pi of x to 5 over 5 plus 4 pi of the x cubic over 3 plus 3 pi x. Okay, and everything is going to be evaluated from 0 to 2. Okay, here I think it's not necessary to rewrite pi each time, so we can factorize it as a common term, and just we're going to have just 2 to 5 over 5 plus 4 thirds times 2 cubic plus 3 times 2. And I'm not going to write minus in the other one because 0 is going to be cancelled here, here, and here, so it's not necessary to rewrite it. Okay, so I'm just gonna have 2 to 5 is 2 by 2 is 4, by 2 is 8, by 2 is going to be 16, by 2 is going to be 32. Okay, so we're going to have 32 over 5 plus 2 by 2 is 4, by 2 is 8, times 4 is 32 again, 32 thirds plus 6, and everything is going to be multiplied by 6. Okay, here we're going to calculate 32 fifths plus 32 thirds plus 6. Okay, so it's going to be 346 over 15. Well, this multiplied times pi, it's approximately 72. Here we're going to write 72.4660 cubic units. This is going to be approximately the volume of this figure. Now let's do it by computer and let's verify that result. Continue with the problem. First of all, we are going to establish the functions. First of all, we are going to make an explicit of x squared. Just x is it's enough for say x squared plus 2. We're going to block the interval from 0 to 2. Click OK, and then as you can see, we have exactly here. We're going to make some zoom. Okay, we have exactly the first one that I need. If you want, remember, let's back to inventory, and you can increase the line, the light thickness. It's better. Okay, and the second one is going to be equal, again explicit, and here is going to be on just 1, block the interval from 0 to 2. Okay, here again, there we go. Okay, this is the problem that we have. First of all, you want to see how is going to be the draw, just go to 1, and here surface of revolution. Okay, here you are going to select the first one. The first one is this one. Around which axis? Axis of x from 0 to 2. See surface, and then you got, I'm gonna close over here, and you got the first surface, as you can see. Okay, it's the first one, and then don't close this part because you are going to select the other one. Okay, from 0 to 2 around x, see surface, and automatically you will have the other one. Can you see it? Okay, and this is going to be just like a speaker, something like that. Okay, we cannot close it. I mean, I cannot close this part and just see that part in the hole here in the middle of the blue one. No, but you can see better the surface that we're going to create, making the revolution of these two functions around the axis of x. Okay, and now we're going to calculate the volume, and the volume is going to be with 2 and volume of revolution. In that case, it's not necessary to say that we are going to say that this is going to be the axis of x is going to be 0, has another function like in the normal example, because here we got the two necessary functions. Okay, remember that this one is just working with the method of the rings, not with the method of the disk. So that's why in the method of the disk you need to add another function called 0. Okay, so in that case we're going to select the first one, that is this one, is the parabola. The second one, that is the constant, and then we're going to say the inferior x is 0, the superior x is 2, and then I'm just going here to press volume. It was for the other example. I'm going to press volume, but before of that, remember that the result that we got in the worksheet was 72.4660 cubic unit. Let's see how much we're going to have over here. Exactly the same. So it means that our exercise on the worksheet was okay, and this is used for verify the solution.